Hello everyone. I had some questions about some of the gas law problems that were on your online homework. So I got some sample problems here and I was going to work for you just to go back and kind of review that and see if you can make sure you understand that. So if we look at this first one here, it says suppose that 3 grams of gaseous nitrogen is placed in a 1.5 liter container. I'm given the pressure is measured to be 421 millimeters of mercury. Okay, so we went over some various gas laws, and that's what one of the inquiry assignments was as well. We have like Boyle's law and Charles's law, but a lot of those were if you have two variables like pressure and volume and you change one of those variables, how is the other variable affected? Like you've got certain pressure, a certain volume, you change the pressure, what's the new volume? And so that's how you know you have to use one of those other formulas. For the ideal gas equation, if you're given 3 of the 4 properties of a gas, then you can solve for the 4th one. That's when you know you have to use the ideal gas equation. Like this one, I'm given the amount of gas, 3 grams. I'm given the volume, 1/2 liters, and I'm given the pressure. So now I should be able to solve for the temperature of the gas, it looks like. Not sure why it doesn't show the temperature there. We'll solve for the temperature of the gas. And so let's go ahead and solve for the temperature. I'll add that to it. Okay. And so ideal gas equation is PV nRT. So P is the pressure, V is the volume, N is the number of moles, R is the gas constant, and T is temperature, and the temperature has to be in Kelvin. So the gas constant, I remember, is 0.0821 liters atmospheres moles Kelvin. You can look up like gas constants, and you'll see a lot of different gas constants here. So this is the one. I can't see that on this side. Okay. So this is the one I'm using here, the 0.0821 liters atmospheres mole Kelvin. There's a lot of different ones that you could possibly use. You just want to make sure whichever one you use that the units match up with the other quantities. Okay, so this is the one that I remember. And so I'm given a pressure, I'm given a volume, I can find my number of moles, I can find N for my 3 grams, I know R, I'm going to solve for T. I'm just dividing both sides by NR, solving for the temperature. Now if I look at my gas constant here, my pressure is in atmospheres. What I'm given is millimeters of mercury. So I have to convert that to atmospheres. So you can look up the conversion factor, 760 millimeters of mercury in the atmosphere. You could look that up if you didn't know it. So I take 421 divided by 760 to get 0.554 atmospheres. Okay. Volume is 1.5 liters. Liters is in my gas law, so that's fine. number of moles. And so I'm given 3 grams of nitrogen. So nitrogen is 14.01, so about 28.2. So I take 3 divided by 28.02, or you can just do 3 divided by 28. So you get 0.107. So I'm going to use that for my moles up here. And then my gas constant. That way my atmospheres cancel out, moles cancel out, liters cancel out. I'll be left with my answer in Kelvin. So 0.554 times 1.5 divided by 0.107 divided by 0.0821. I get 94.6 Kelvin. And now that answered this problem. Let's change it up a little bit again. So we'll say, ask, what is the temperature of the gas in degrees Celsius? Okay. And so now you have to convert Kelvin to degrees Celsius. So if you have a Celsius temperature, you have to add 273 to that. So if you have 0 degrees Celsius, yeah, it's minus 273. So for this one, you need to subtract 273 to get the Celsius temperature. And so I want to take the 94.6, subtract the 273. So that gives me about minus 178 for the temperature of the gas. And so remember, there's no negative values in Kelvin. Don't remember that. And you can also look at your conversions. So 0 to Kelvin, so you add your Celsius temperature there. Let's go ahead and look at another problem. So this is, consider the reaction 2H2 plus O2 yields 2H2O. If this reaction were done at standard temperature and pressure, what volume in liters of H2 gas would be required to react completely with 44.8 liters of O2 gas? And so I want to go from one compound to another compound. Okay, so I'm given what volume of H2 gas will I need if I have this amount of O2 gas. So to go from one compound to another compound, I have to use a mole ratio for my balanced equation. Okay, so I need to know the number of moles. So I'm going to start with what I'm given. So react completely with 44.8 liters of O2 gas. I'm going to start with that. Now I'm given that this is at standard temperature and pressure. Or at standard temperature and pressure, if you plug those conditions into the ideal gas equation, you get that 1 mole of any gas has a volume of 22.4 liters. So I'm going to use that. So I know at STP, 1 mole of any gas, including oxygen, is 22.4 liters. Okay. So my liters can cancel out that way, and I have moles of oxygen. I'm trying to go to liters of H2 gas, so I go to my balanced equation. Okay, look at the coefficients from a balanced equation. 1 mole of O2 reacts with 2 moles of H2. So now I know how many moles of H2 would react with this. That says what volume of it. So again, I can use that same relationship. Say 1 mole of H2, 22.4 liters of H2. So your 22.4's about to cancel out, so you'll just take 2 times 44.8. So you get 89.6 of H2. Here's another one with from the ideal gas equation. So it says a 5-liter container is filled with 0.8004 grams of helium gas at 117 degrees Celsius. What's the pressure of gas in atmospheres? So this is going to be more like the first one we worked. So what is the pressure of the gas? So I'll solve for pressure. So I divide both sides by the volume. So number of moles I have 0.8004 grams of helium. So I need to convert that to moles of helium using the atomic mass of helium. I'll go ahead and check this. .003, I guess. I'll say it's approximately 2. So we'll plug that in. Gas constant. Remember, the one that I remember is the one that's in liters, atmospheres, moles, Kelvin. Temperature, now I need this in Kelvin, so I need to add 273 to this one. And then volume, 5-liter container. So all cancels out, and I'll be left my answer in atmospheres. So 2 times 0.0821 times 390 divided by 5. So I get 9.5. I'm looking at significant figures here. Looks like I need to go to 3. So 9.52. Okay, let's look at another problem. So So it says the gas inside the balloon is characterized by the following measurements: pressure, volume, temperature. What's the number of moles of the gas in the balloon? So now I'm looking for the number of moles, so I'm solving for the number of moles. So I need to divide both sides by RT. So pressure, I'm given in millimeters of mercury. Remember, my gas constant that I remember is in atmosphere, so I need to convert this to atmospheres. So in 1 atmosphere, there's 760 millimeters of mercury, so that'll cancel out. So you have 0.97. Volume, 100 milliliters. So, again, my gas constant's in liters, so I need to convert that. So it's in liters, atmospheres, moles, Kelvin. Temperature, 27.5 degrees Celsius. Need to add 273 to that. So 300.5. And for these, all these gas laws, the temperature has to be in Kelvin. Kelvin cancel out, liters cancel out, atmospheres cancel out, and I'm left my answer in the number of moles. So if I go to 3 significant figures, I get 0.00393, so that'd be times to the minus third moles. Or you could write it out 0.00393. Let's look at one more. So this says 1.95 gram sample of gas of unknown identity occupies 2.6 liters and exerts a pressure of 0.5 atmospheres at 0 degrees Celsius. What's the molar mass of the gas? And so if I think about my ideal gas equation, PV equals nRT. For pressure, I know. Volume, I know. I know my gas constant, I'm given the temperature. I'm not given the number of moles. I'm given 1.95 grams, and normally I can find the number of moles if I know what the gas is, so I can find the molar mass, but I'm not given the molar mass, so I'm going to solve for my number of moles. So pressure, .4 atmospheres, volume 2.6 liters, gas constants 0.0821 liters atmospheres moles Kelvin, and then 0 degrees Celsius or 273 for that in Kelvin. So why am I solving for the number of moles? That's not what the question asks. It doesn't say how many moles do I have. It says what's the molar mass of the gas. But I know molar mass is grams per mole. Well, I'm given the number of grams. Okay. So right here, I'm given the number of grams. If I find the number of moles, I can take grams divided by moles. That would be my molar mass. So 0.4 times 2.6 divided by 0.0821 divided by 273. So I get 0.0464. Okay. Now my molar mass. 1.95 grams divided by 0.0464 moles. So you get 42.0 grams per mole. Now if I look at the next part of this, it says combustion analysis determines the empirical formula of the gas is CH2. What's the molecular formula? CH2, if I know carbon's 12 and hydrogen's 1, so that has a molar mass of 14. So CH2 is 14. My unknown has a molar mass of 42. So what times 14 would give me 42? So I just take 42 and divide by 14, and it's 3. So that tells me I need to multiply my empirical formula by 3 to get my molecular formula. So 1 times 3 would be C3, 2 times 3 would be 6. So C3, H6 would be my molecular formula then. So I hope that helped kind of clear that up for those of you that may have been a little confused with that homework on Chapter 11. Let me know if you have any more questions. Bye.